So our next concept is our property of equality for logarithmic equations. So this is very similar to the exponential property where the bases were the same, so the exponents could be the same. If we have a log equation where the base is the same on both sides, then we know that the arguments, so x and y, are also equal to each other. So if we notice that we have the same base on both sides, for a log equation, then we can just set the arguments equal to each other and we can solve. Okay. So in example 3, we're going to look at solving exponentials using logarithms still, but this one is a little bit more challenging than what we saw in example 2. So we have 2 different bases, and we know that we can't rewrite 3 and 5 as a common base. So that tells us that we need to take the log of both sides to get started. So I'm going to take log base 10 of 3 to the x plus 1. I'm going to set it equal to log base 10 of 5 to the x. We can use our power property to bring both of those exponents out to the front. So I can rewrite this by bringing x plus 1 and x out to the front. So I get x plus 1 times log of 3. And I have x times log of 5. We can expand out the left side of our equation by distributing log of 3 into x and plus 1. So I have x times log 3 plus log 3 is equal to x times log 5. Right. And now at this step, I'm thinking of ways that I can maybe factor something out or get x to be on one side. So I'm going to bring my x's over to the left side of the equation, and I'm going to bring my log of 3 over to the right, because I know I can evaluate log of 3 and get an actual number, but I need my x's to be on one side for that to happen. So I'm going to subtract x times log of 5, and I'm going to subtract x or log of 3 in order to move them to each side. So now that I have my expression with x on the left side and my log of 3 on the right side, I can think of factoring out a GCF from each of these terms. So if I have a coefficient of x in both of my terms on the left side, I can factor out that x out to the front. So now I have log of 3 minus log of 5 equals negative log of 3. Once I factor out the x, right, I can use division here in order to bring all of my logs back to the right side and my x's left over on the left side. So x is going to be equal to negative log of 3 divided by log of 3 minus log of 5. Okay? And all of that you can evaluate in your calculator. Right? If you want to use Desmos or your graphing calculator, any of those work. So we're going to type it in exactly as we wrote it out. And so here we can see that x is approximately 2.15. On our graph here, we have two different functions. So our notes actually give us the two equations that are graphed separately, and we're looking at the intersection point. So our blue function is going to be the left side of our equation that we start with, so that 3 to the x plus 1. And our orange equation is that 5 to the power of x. So if we look at their intersection point is 2.15, comma 31.8, and that x coordinate matches what we solved for algebraically. So it's just another way to check our solution. Okay. So next one I want you to try out is number 3 on the next page. Okay. Very similar to example 3 that we just went over. If you want to check your solution beyond checking informative, again, you can graph each of these separately on Desmos and look for that intersection point just to confirm your solution.